Hi everyone, welcome to my YouTube channel, City of Electrons. So in this video, we're talking about the third project in the Arduino project handbook by Mark Geddes. Now, this is bar graph, and in this project, you combine what you've learned in the previous LED projects to create an LED bar graph that you can control with a potentiometer. Now, when you hear this, see, forget about the complexity. This is not complex. Just think of this. When see, in church sound, or okay, even not in church sound, but when you talk with a microphone or mic or whatever, and usually in amplifiers or mixers, you see this thing. When someone is talking with a microphone, when he's really loud, you see, like, he's talking continuous signal, like he's talking, the person is talking, you see like the LED or lights in the mixer responding something like this. The light turns on according to the intensity of the input signal, maybe voice or whatever. Okay, so that picture in mind, with that thing in mind, that's what we want to do. However, we do not have a mic input here, so what we are going to use as the input is what? The potentiometer. Okay, the potentiometer, yeah, this guy right here, the potentiometer. So when you turn this thing, as you turn it, it's like you are increasing the intensity of what is coming in. So what is going to happen? The light will light up accordingly. So if you reduce this one, the lights will turn off and you get just this like almost nothing. So as you increase this, you get more lights turned off. Okay, so yeah, so let's go to the connection. So we have all our components here. So we'll start by doing this, negative to this side and positive to this side. So what we'll do now, we just connect the negative leg of this guy to the negative rail already. Okay, by doing this. Okay, so I have to spread this guy a bit. So the negative will be here, and then the positive here. So you see what I've done now. Okay, so by doing this, we have this guy pinned in the negative like this. So I don't need the extra wire to connect the negative. I already have it pinned in the negative. Okay, I already have it pinned in the negative, and then positive. This positive part is where I will now connect a resistor to. Okay, so we have it something like this. Okay, and then of course from this part, from this, so negative and then positive, of course this part is where I will connect a pin to the microcontroller. So microcontroller. So this will be, so you know, like we are starting from pin 2, you know that we ignore 0 and 1, because 0 and 1 are for receiver and transmitter, RX and TX, RX and TS. So we'll now start from 2. So this guy will go to, so it will go to this first part. So you can see that. Okay, so I just connected 1 because I'll connect the remaining 8 like this. So negative leg, negative side, positive, which is now connected to the resistor, and then from the resistor, that's pin to pin 2 of the Arduino. So I will just connect the rest like that. Okay, the next one, and so on like that. Now, right, so there we have it, just the same pattern repeated over and over again for each LED. Okay, all right, so the next thing now is to connect the potentiometer to it. Okay, our variable resistor. So we'll just plug it somewhere. Now if you look at the text, the book, if you look at the book, maybe my positioning, where I position each component, may appear a bit different from what you have in the book, but it's the same concept. There's no strict rule like you must place it on this part on the breadboard. It's just the breadboard just hold the components in place. Okay, but of course where you place it will now affect how in the direction of your wire, but it's the same. The wire is going to the same component, okay, but maybe from different angle now. Okay, so we have this guy there. So all we have to do is to let's connect the 5 volts of the Arduino. Or let me use this for 5 volts of the Arduino to power the positive rail. Let me just put it closer. Positive. Enter, enter, enter. Yeah. Then I will use for the negative. That's for the ground. This for the ground. Okay. Can I get all the way here? Let me just place it here. Okay, close to this guy. Let me just place it here. The thing is, having it like this still means everything here. See this guy, negative. So all this line, all this first line, all this line here, okay, that's blue parts, they are all what? Negative. So I can even extend from this part, extend from it. Let me just even put it here. I can extend from it to this side. Okay, so what I've just done by doing that is bring the negative, that's ground, this yellow one placed here. This connection, I extend it from here to this part. Okay, meaning this, all the LEDs here are now connected to ground. Okay, like I said, because of the different positioning, I place the components kind of different position from where the textbook is. That's why I have to do all this many extension. Okay, so now all these LEDs are connected to ground by doing this, and I can connect this guy to ground now, the potentiometer. Let me do that quickly. Connect this part of it to ground, which is this guy now, and then let me connect it to live by doing this. Okay, and then the center pin we know is going to, center pin of it is going to what? The analog in. All right, so look at it, we have our setup complete. Okay, we have our setup complete. All right, so if you have any question about the setup, please let me know in the comment section, and I will reply to that. But this is our complete setup. Now we can go to the program, write the program for it. Okay, so let's write the program for it. So let's say bar graph program. Downloading what now? Bro. All right. So of course we declare the variables instead of using pin this, pin that, we use readable language for it. So of course they are integers. Then because 1 2 3 4, those are integers. Now I want you to bear in mind, instead of us to do this, LED 1 will now say that's pin 2, int LED 2, they will say pin 3. Come on bro, that's going to take us like, okay, it won't take long, it will work, but there's a better way to do it. Arrange this thing in a set. Sorry, like this is how we write sets: 2 3 4 5. So now we are saying pin 2, pin 3, pin 4, pin 5 to what? We connected to, make this thing, we connected to pin 10, right? Yes, we did, to pin 10. So we are going to write this thing to what? Pin 10. 6 7 8 9 and 10. Good. So this is so now we've taken all the pins, pin 2 3, all the pins, we have set them into what? One particular variable. Now this is what? An array of what? Integers, integer array. So we are going to do what? Put this sign here, indicating that this is what? An array. It's not just a variable, it is what? An array. Array contains multiple elements. And what? How do you identify an element? How do you identify Elements are what you have inside the array. How do you identify an element in an array? How to identify an element in an array? You use the name of the array and the index of the element. Index just means the position of the element. So in this, I think the ID is trying to help me here. Thought you were showing something now. Okay, so to identify any element, you need the name. Okay, now they are telling us int. Yeah, expression type int 9, meaning there are 9 elements in this array. In this array LED. Let me even add LEDs. Okay, so the position of these elements. Now this element now is what? Pin 2 of the Arduino. Pin 2. Now that's the element. But the position of this element is what? Index 0. Counting offset, you start from where? Index 0. Index 1 and 2, 3, 4, 5, 6, 7, 8. Being that we started out, we count from 0, so we count, so the highest index will be what? 8. But how many elements? 9. So when you say LEDs, and you put index 0, you are referring to what? Pin 2. Exactly. So now we have that there, and as you know, we can add more variables to this place when the need arises, so you know what we are doing actually. So we'll leave that. Now let's go to setup. So set the pins to what? Output, because they are all output now. So to set the pin to output, instead of to pick one by one, we are going to write a loop that will set the first one, loop to the next one, set it to output again, loop to the next one, set to output, loop to the next one, set to output. So we are going to use a loop to set each one to what? Output. The loop will run through the elements in the array, so we can use a for loop for that. For int, let me say I, but let me use something that is quite related. Int L, something like for LED. Okay, so going from index 0, let me not say index, going from 0 to what? The reason why I say int is that I'm declaring that this letter L is an integer. Okay, we are counting from 0 to where? L less than what? 9. Why less than 9? Because we are going to count how many times? 9 times. We are not going to get to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8. That is 9. If we get to 9, it is what? 10. 10 counting, or 10 times. But we need just only 9 times. Assuming we are starting from 1, we can now say less than or equal to 9. But we are starting from where? 0. Okay? So they will now say L plus plus. This L looks like 1, oh bro. Let me just use LED, I beg. LED equals, what am I doing? Okay, better. LED equals it, then this one too will be LED. So the set is LEDs. Then we are using LED to represent the count. Okay. Now the loop will go from taking LED as what? 0. So for the first count from 0, what will happen? We say pin mode LEDs what? LED what? I'll explain what's going on here. Okay, output. Now what's happening here? We are setting the pin mode. So this pin mode for the set LEDs, I said to identify this thing should stop. I said to identify a particular element in an array, you need the what? The name of the array. Look at it here. Oh boy, you need the name of the array. Look at it here. The name of the array, and then the index of the what? Element. So now, and you know this loop is going from where? 0. So at the first loop, the first iteration, or let me say the first count, LED is what? 0. And 0 is the index of what? The first element. Meaning, this first count we are setting, what's in the first element? Pin 2. We are setting this pin 2 to what? Output. Is that clear? Then after this, the loop will go again. After this, the loop will do what? This LED plus plus mean after we have done the first thing, it was 0. Plus plus mean increase by 1. Increment operator. Let me just say increment. So increase by 1. So after this has been set, LED is 0, which is index 0. Name of the array, position, in this case 0, which is addressing what? The first element. So once that has been set to output, then the second iteration, this guy will be increased to like plus plus, which is 1. So here will now become what? 1. So now this position now will be changed to what? 1. This position now will be what? I don't need to write the 1, please. It will now be 1, which is what? Index 1, and that is what? This guy. Are we following? So this thing will continue. After this 1, which is the pin 3, has been set to what? Output. The loop will go again. Plus plus. So here will become what? 2. Here will become 2. So what's in index 2? This guy. Pin 4 set to output. Just like that till the end. Please, is that clear? Let me know if that's not clear in the comment section. Please let me know. Okay? So with this, we set all the pins to where? Output. Is that clear? Okay, so the next thing is to start our loop. Oh, in case you are saying in the comment section, what about this? I just remember we've not declared our analog pin. This is for input. Sorry, this is for output. Okay, LEDs for output. How about the input? Potentiometer. I forgot that component. Potentiometer. So it's in where? A0. And you know, analog pins, they are already input pins, so I don't need to declare analog for input whatever. I don't need to because analog pins are already input pin. So for our loop, what we are going to do is this. We are going to read the potentiometer value. Read the potentiometer value. So let me just say because it's analog pin, you say what? Analog read. Maybe so. Analog read, and then ports. So we are reading the potentiometer value. I will save it inside where? And let's say value. Save it inside value, but we've not declared value, so we'll come here and declare value. Int value. Good. Yes, we tell this one, and that's how we will do maybe now. Okay. So I believe that's clear. So after reading this thing, then you do what? Remember that our input pin is coming as what? 10 bits. 10 bits, which is what? 2 raised to power 10. This is not part of the program. I'm just doing it to show you, like 2 raised to power 10, which is what? 1024. There's a function inside Arduino, which is map. So what are we mapping? We are mapping value. That is what we've read. Value, and it's what? 0 to what? 1023. Okay, hope that's clear. 1023. Then 0 to 9 or 8. Talk to me. 9. Okay. I know some of you might be thinking, you should be 0 to 8 now, because 0, 1, 2, 3, 4, 5, 6, 8. That's 9 values. Yes. However, we said 9 because we are having like if we say 9, it's like we are having 10 steps. Is that not so? If we say 0 to 9, it's like we are having 10 steps. But we have 9 LEDs. I should do 0 to 8, Abi. If I do 0 to 8, this one is 9 steps, which is exactly 9. But if you do 9 steps, where is your step for off? First LED on, 9. But what about that step where no LED is on? That is 10 steps. So that means we are moving from 0 to what? 9. Whew. Please hope this 0, 9, 10, 8. Are we clear with that? Let me know in the comment section. If I have to make another video to explain this thing, I will. Just let me know in the comment section if you get it or not. So 0 to 9. Now this mapped value will be saved to here. Let me call it m value. So we have to declare that one too. Int m value. Okay. Now we are going to do this. Let me push this guy down a bit so that I can see what I'm doing. So now what we are going to do now is to check each LED. That position. This is index 0, index this, index that, index like that. So we are going to use the index value of each LED, compare it to the mapped value. Okay, meaning so first of all, we need a loop to run through all the LEDs and map each of them one by one towards 0 to 9. Now since we've done this mapping, m value now is giving us 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 whenever we turn the potentiometer. So if the potentiometer is not turned at all, like it's 0, this will map to what? Like nothing. So let me just write the loop that will do what? Run through all the LEDs. We already have that now. This loop runs through all the LEDs, counting from index 0 to what? Index 8. So let me just paste that here. Okay. So now we have the map value as 0 to 9. We have the LED value as what? 0 to 8. Now we say if what? LED, which is this one, this is at the first iteration, this is 0. So if 0 is less than what? M value, which is the map value. So if the potentiometer is at what? Let me say we move it to 1. If the potentiometer is at 1, value 1, that means LED, which is the first index, 0, is less than 1 abi. Then we can do what? Turn you can say what? Digital write. Then we can say to turn on that particular position of LED, we say what? LEDs, because we are trying to identify that LED. How to identify a particular element in an LED? We need the name of the array. Sorry, how to identify a particular element in an array? You need the name of the array and the index. Of course, LED here is giving us the index, which is what? Index 0. Index 0. So if 0, which is the index 0, is less than the mapped value where you want your potentiometer to, then digital write, that's the element, which is what? The array name and the index of that array, which is 0 in this case, should be what? High. Good. High. Else digital write LEDs LED low. Good. So this will go through all the elements. Let me give some more space here. So if the LED index 0, and we've not wind the potentiometer at all, potentiometer value is 0, that is the mapping here is 0, it will not turn on because 0 is not less than 0. It will not turn on. So you see how the logic is working now. So that's why this one we have 0, 1, 2, 3, 4, 5 to 9, which is giving us 10 steps. So we have 10 steps to wind our LED. The 0 step where we've not wind at all, the 0 step is will give us an opportunity to have this thing to be false, so that the LED can be, all LEDs can be off. Okay, when we start moving it, step 1, now that one will be higher than this index 0, so this one will be on. If we move to step 2, this one will be less than 0. It will be less than, sorry, oh Jesus. If we wind the potentiometer to step 2 is greater than index 0, and so element at index 0 will be what? On. Then to check again, it will increment LED, increment to 1, so this will become 1. 1 is still less than 2. That means elements at index 2 would also be what? On. So we have two LEDs on. Are we following? So also increment to 3. 3 increments to 3. So this will now be 3. Then 3 is greater than step 2. So 3 will not be on. Just like that. Please, I need comments to know that you guys are following. Okay. So this is all for the program. This is all. So I can load this now. So let's see how it works. Uh-oh. Something is off. Something is off. Okay. This guy. Noted. Semicolon. Proper contact, but touch where? Oh, Bob, these other guys are bright, you know. So if you observe, this one is not really that bright. I used 220 kilo ohms. Then this one I used 1 kilo ohm higher resistance for this one, and it's because I ran out of 220 resistor. So these guys look a bit dim, but these other guys, woo! Okay, so you get the point. So that's it. So thanks for watching. Like, share, subscribe, and bye for now. Like, share, subscribe, and bye for now. Yeah!